Okay, in this example we have a cyclist travelling at 16 km per hour when she reaches the top of a hill. She pedals down the hill with constant acceleration of magnitude 1.2 meters per second squared. Given that the length of the hill is 130 meters, we need to calculate the time taken for the cyclist to reach the bottom of the hill. To answer this question, we'll first write down our values for SUVAT. The length of the hill is 130 meters, so we'll call that the displacement. To find the value of u, we need to first convert the 16 kilometers per hour into meters per second. To do that, we first enter 16 into our calculator. Then we press Option. To get to the next menu, we press F6. We press Convert. We're converting a velocity, so we need to go to the next menu. We choose velocity. Then number 2 is kilometers per hour. Then we put a black triangle on. And then we choose velocity again, and then meters per second. Pressing EXE tells us it's 4.4 recurring. So 16 kilometers per hour is approximately 4.4 meters per second. Don't forget we want the exact value for this, so we store it in our calculator as A. We also know the value of the acceleration, that's 1.2 meters per second squared. And the quantity we're trying to find is t, and we're not interested in v. Next, we select the appropriate SUVAT equation. We have S, U, A, and we're trying to find t. That means we want S equals ut plus half at squared. So S is 130 equals u times t, that's 4.4 t, plus a half times a, which is 1.2 t squared. To solve this quadratic, we'll make the left hand side 0 by subtracting 130 from both sides. That gives us 0 on the left hand side, and reordering the terms, a half times 1.2 is 0.6, so we'll put the 0.6 t squared first, plus 4.4 t minus 130. We'll solve this equation directly using our calculator. For the t squared term, we enter 0.6. For the t term, rather than entering 4.4, we use the exact value that we stored by entering A. And then for the constant, we enter negative 130, and we press EXE. That gives us two values for t. We get t equals 11.47 and so on. And we get t equals negative 18.88 and so on. Since the value for time must be positive, we get t equals 11.5 if we round to 3 significant figures. Okay, here's a problem for you to have a go at for yourself then. Pause the video and then come back and check your solution against mine. Welcome back, here's my solution. Don't forget to check your written communication as well as the answer. If both of them are fine, move on to the next example. If you got anything wrong, I'm going to go through my solution now. So we have a train travelling at 140 km per hour. At point P, the driver applies the brakes, producing a uniform deceleration of 0.6 meters per second squared until the train reaches point Q, which is 1.25 kilometers from P. We need to calculate the time taken for the train to travel between P and Q. As always, we'll begin by writing down our SUVAT values. We know the displacement is 1.25 kilometers. We'll write that as 1,250 meters. The initial velocity is 140 kilometers per hour. Let's turn that into meters per second. We type in 140, then we go Option, Convert. We want a velocity, kilometers per hour, and we want to turn it into meters per second. That gives us 38.8 meters per second. Let's store that value in our calculator. We're told the deceleration is 0.6 meters per second squared, so we write a equals negative 0.6 meters per second squared. We're trying to find the time, and we're not interested in the velocity. Next, we need to choose the appropriate SUVAT equation. We have S, U, A, and we want to find T, so we choose S equals UT plus a half AT squared. So S is 1250 equals 38.8 T plus 1/2 times negative 0.6 times T squared. A half times negative 0.6 is negative 0.3. But so that we've got a positive T squared term, we'll imagine moving everything over to the left hand side. That gives me 0.3 T squared. To move the 38.8 T over, we'd subtract that. And the 1250 is already on that side, so plus 1250, leaving us with 0 on the other side. Let's pop this into our calculator. We need to go into equation mode. We choose polynomial, degree 2. We enter 0.3 for A. We use our stored value for B. And we enter 1250 for C. That gives us two values. The smallest of those is 58.95. And the other value is 70.67. Here it's not as obvious which one we want to choose. It looks here like there are two times when it will be at a displacement of 1.25 kilometers. And that's because the equation we're using to model this, S equals UT plus half AT squared, it doesn't take into account that we would expect that when the train reaches a velocity of 0, it would stop. Modelling it with this equation, it would continue to then accelerate in the opposite direction, essentially turning round and going back the other way. That's where the 70.67 comes from. So for this question, our value of T equals 59.0 to 3 sig phi.